Hello, everyone. My name is Saurin Shah, and I'm a product manager in Snowflake. Today, I'm going to talk about Enterprise Lakehouse and all the product launches that we are doing today. And we are going to see some exciting demos. As part of my job, I talk to a lot of data engineers like you. Uh, Mostly, what I hear from all of you is that your job is to move the business forward. Your job is to make sure that you can unify all of the data sets in your entire data estate together into a single lake house and then make it available to your business teams. You want to make sure that all of the security policies for your entire data lake is all super tight, it's well governed, and then you want to make the data AI ready or analytics ready and give it to your business teams. However, from almost like many of the customers and many of the data engineers in our customers' organizations, we have been hearing that this has been super challenging. The architectures are breaking. There are three main reasons for this. The data is all fragmented. The data exists on multiple different systems, on multiple different clouds, on multiple different SaaS vendors. And to top it off, the security policies in all of the systems are completely different. It's been very, very difficult to unify all of the security policies and in these siloed copies. What it turns out to be is that the entire data architecture becomes super complex and expensive to manage. And lastly, you get a very diverse set of requirements from your diverse teams. Sometimes there will be an AI team, an analytics team, and some other teams, and everybody has very different requirements. So all in all, like we've been hearing from data engineers like you, is that there have been complaints like, can I trust this data? Oh, the pipeline is broken again. Why is the pipeline paused? And you've been dealing with all of firefighting rather than actually working and building and innovating on your data pipelines. To top it off all of this, the existing lakehouse vendors, when we investigated and when we looked at it, the existing lakehouse vendors, they actually calcify silos. They force you to take a dependency on your catalog. They force you to bring everything together into their own catalogs and into their own engines as well. In short, this is all locking you into the complexity. Lastly, what we have been hearing from many of the data engineers like you is maintaining disasters has been extremely challenging. Like a few days ago, AWS had an outage on the US East region, and it was very difficult for many of the customers to move their entire lakehouse and manage the disaster recovery during that period. So we think there is a better way to build an enterprise lakehouse. We have been looking at this problem for the last couple of years, or at least the last year, and we have been trying to solve it in such a way that you can overcome all of the challenges that we talked about. It really starts with foundational enterprise security. What you want is a centralized place where you can govern your entire data estate. You can conquer data complexity by bringing everything together into a fully managed platform. It doesn't matter where your data is stored, whether it's stored on AWS or Azure or GCP or even on-prem, you should be able to get a single view of your entire data estate and provide security, like enterprise security on top of that, all of that. And lastly, what you really want is to seamlessly empower your business teams. You want to empower all of the workloads like AI, analytics, applications, data engineering, and give all of the empower your teams who are using those workloads in a very seamless manner. So let's dive deep into this on how you can achieve this. It all starts with the Snowflake Horizon catalog. Snowflake Horizon catalog now empowers interoperability through open APIs like Apache Polaris and the Iceberg REST catalog APIs. This is really groundbreaking. What it really means is if you have Snowflake managed Iceberg tables in your Snowflake account, these Iceberg tables are now interoperable and you can have multi-engine access, both read and write, through these APIs, through the open APIs that are available on the Horizon catalog. So if you have a Snowflake account, which you have been using for a long time, and if you have built your Snowflake account in a way that you have the foundational enterprise security and your entire data estate through that account, you can now expose the Iceberg tables to multi-engines. And we are going to see a demo for that one. So today you're going to see 3 demos. The first one you're going to see is the secure multi-engine access. You will see how we can have Snowflake managed Iceberg tables in your Snowflake account and expose them via the open APIs in the Horizon account. These we will see how you can use a Spark cluster running on Databricks to actually query these Iceberg tables, do read queries on the Iceberg tables. The second demo which you're going to see is about enterprise security, where you can have role-based access control and even fine-grained access control on your Snowflake managed Iceberg tables, and will replicate them from one deployment to another deployment, from a US West to US East. And imagine that a disaster happened, and then how you can go to the US East deployment and query these tables. The cherry on top over here is that you will have fine-grained access control, and you will see how fine-grained access control policies also get replicated over to the secondary deployment and get then applied on the secondary deployment. And then lastly, we are going to see a demo of accessing any Iceberg tables. Let's imagine you have Iceberg tables running on multiple different clouds and they are registered in multiple different catalogs. How can we bring all of these together into a single view and still run analytics on top of these? Okay, so let's jump right in. The first demo, as I mentioned, is going to be OSS-powered interoperability using Horizon. So we'll see that you have Snowflake managed Iceberg tables, and we'll expose these Iceberg tables via Iceberg REST APIs and then query them using Spark. The storage for all of these managed Iceberg tables is going to be stored in customer storage. After we do that, we are going to see an Iceberg v3 support demo for that. As you all know, Iceberg v3 was launched in the OSS community sometime around the July timeframe, or June or the July timeframe. Snowflake had a bigger contribution to that, where we contributed to many different features like the variant data type, geospatial, row lineage, and many more. Since then, we have been working on how we can have the v3 support in Snowflake as a managed service itself. And I'm excited to say that this is going to be private preview soon. We'll see a demo for that one as well. Okay, so let's just jump right in. Here, I have a Snowflake account, and in the Snowflake account, I'm going to create a data or use a database. I'm going to use a schema, and if I say show Iceberg tables, there is actually an Iceberg table. So let me first clean up that one. Okay. So now I go and say show Iceberg tables. So there are no Iceberg tables in this account. Let's start from scratch. So the first thing which I'm going to do is create an external volume. This external volume connects to my Esha bucket in AWS. And what I've done is I am going to assume this role, because this role has privileges to access my my bucket. So going back over here, I've already done creating the volume. So if I do a verify volume, I will see a success. So now let's go ahead and create an Iceberg table. You will see this is a Snowflake managed Iceberg table, and I've intentionally kept the Iceberg table as super simple. It just has 3 columns, an ID, a timestamp, and a payload. I'm going to insert some data, sample data into my Snowflake managed Iceberg table, and I'm going to run a select query from that. So you see there is one record in this Iceberg table. Now what I want to do is I want to go to Databricks, and I want to use a Databricks notebook and a Spark cluster to actually query this Iceberg table. I've already created a demo cluster over here. If you see, this is the demo cluster. There are some things to point out over here. So in this demo cluster, I have actually an access mode as a manual and a no isolation shared. This basically says that there will, this won't be able to access the data in Unity catalog. And the main reason over here is if you use a Unity catalog in the Databricks cluster, then you cannot access any other catalogs. So we have to go and do this. I have some Spark configuration set up, and that's all you need to do. So let's now go to the notebook. And in the notebook, I'm going to run these commands. So the first command over here, which I run, is connecting or setting up the Spark config. You will see that I have a personal access token from my Snowflake account. I'm going to assume the role, which is the account admin. I'm going to connect to a S-shard database. And that's all. And now if I run a query, you will see that I am able to actually show the namespaces, and I'm going to show the tables in the schema. You will see that I can see my Horizon Iceberg table, which I just created. And if I run a query to select the data, you will see that I can able to actually query the records, which we just created over here, the sample data in the Snowflake managed Iceberg table. So this was super easy. I created a Iceberg table in Horizon, or in the Snowflake in the Horizon catalog. It's a Snowflake managed Iceberg table, and I was able to query that using Spark cluster running in Databricks. So now let's just jump into the second demo, which I was saying is the Iceberg V3. So for this V3 table, I'm going to create a new table, service events. And if you see the data variant, data type over here, it's a variant data type. If you see the Iceberg version, this is an Iceberg version 3. So this is a V3 table using the variant data type. What I'm going to do now, if I do a select, there is no records in the table. So I'm going to copy over some JSON files into this table. If you see here, I've copied over a few JSON files. And now if I run a select star, you will see that the data has been populated. There are about 90 rows into this table with the variant data type. What's cool in this is not only the data is in the variant data type, I can extract the subcolumns from the variant data type here as well. So if I run a select query, you will see that I have extracted the service column or the subcolumns from it. But not only that, I can also use the subcolumns in an order by clause. So if I run a select query over here and order by this P95 latency millisecond column, which is actually a subcolumn or an evaluated subcolumn from the variant, I can still use that and I can run queries based on that. So this is super cool. This is like the power of variants, which had been on Snowflake native tables for many years, is now available on Iceberg tables and in open source as well. And like how I created or I queried this Snowflake manage or a Horizon Iceberg table in Databricks, I can also take this V3 table, go to the Databricks cluster or a Spark cluster, and then I can query that V3 table from that as well. So this is interoperability at its best. Like, it's the power of variant, but now available in a V3 table and interoperable as well. Okay, so going back now, let's jump to see what the second demo is going to be. So in the second demo, what we are going to do is we are going to create granular policies for Iceberg tables. And these policies will be applied. These are fine-grained access policies. They will be applied to Iceberg tables in Horizon or in Snowflake managed Iceberg tables. And then I'm going to replicate those Iceberg tables from the primary deployment to a secondary deployment. So it's interesting to see what the replication over here would be. So when we replicate the table, if you remember, the data was stored on a bucket which was in US West. And now it will be replicated to a data, now a secondary deployment to a bucket, which is in US East. So we'll see how the data gets replicated not only on the buckets, but also the metadata on the Snowflake side will get replicated from the US West to US East. What the catalog will also do is the tables on the US East, we will make sure that these tables are read-only so that it's a true active-passive scenario. And lastly, we'll also see that how the policies get replicated from one deployment to another deployment. So let's jump to that demo. So if you see the same account that we had, now I'm going to create a new database called replication demo. So if you see, I created a new database, and in that database, I'm going to create a Snowflake managed Iceberg table. I'm going to use the same external volume that we used before. So that's on, so the data is all stored on an AWS. And I'm going to insert a record, a very simple record. Now what I'm going to do is I want to replicate this from US West to US East. So what I'm going to do is I'm going to add a new location to my external volume, and the bucket will be Shahi US East. So let's add that new location. And if I show replication accounts, I want to actually replicate it to this account. So what I'm going to do is I'm going to run this command, which gives me the IAM user on the US East. And I'm going to take this IAM user and put it in my trust relationships so that IAM user can also assume the Snowflake role. I've already done that, so I'm not going to repeat that over here. So that was all the setup. That's all the setup that I had to do to set up the replication. So now let's create a masking policy. And I'm going to apply this masking policy to the table that I had just created. And I'm going to create like failover groups. So the first failover group will replicate all the external volumes from the one deployment, primary deployment, to the secondary. And then the second failover group is going to replicate all of the databases, specifically the replication demo database from the primary deployment to the secondary deployment. So this was all the setup that I had to do on my US West account. It's super cool. It's super easy. Now let's go to the US East account and see what needs to be done on the US East account. So first, I'm going to basically show you that there are no databases over here except the Snowflake default database. There is no database. It's a brand new account. There is no database. Let's show the external volume. So there are no external volumes here either from this over here. So this is completely like a brand new database. I'm going to switch over the role to account admin. Okay. So now I'm creating a failover group. This failover group, if you remember, was for my external volumes. And I'm going to refresh the failover group. So that's all it's needed is just these two commands to refresh. And what it's going to do is it's going to bring the external volume, which was created on the West account, to the East account. So if I say show external volumes, now I can see the Iceberg demo external volume, which was created on my West account. Now let's bring over the database as well. So replicate the database. I created a failover group from my West account, and let's refresh the failover group. It may take a while because it's replicating the entire database from US West to US East. So it may run in a few seconds. So it's completed. Now, if I say show databases, I see that the database has been replicated. If I say show Iceberg tables, you will see that the Iceberg table has also been replicated. And then if I do a select star on the Iceberg table, you will see that I see the data which I created in US West now available on US East. How easy is this? Like within a couple of minutes, we were able to replicate a Iceberg table from US West to US East. But, I want to show some cool things as well. Now, what if I want to insert a record into this Iceberg table? And the catalog is going to prevent that, saying that the replication demo, it's a read-only account because it's a secondary database and it cannot be modified. So this is how the catalog adds constraints and makes sure that it's always an active passive scenario. And lastly, I want to see if all the masking policies that I created on US West, can they be applied on the US East? So I switch over the role to sysadmin. And if I run a query, you will see on the payload, I cannot see the payload. It's XXXX because on the US West, I had created a masking policy that if the admin is not an account admin, then just show XXX. Do not show the string, the whole string at all. So this is so cool where I had created a policy, a, a security policy, a governed policy on US West, and now it's applied on US East. Okay, so lastly, now let's jump to the next demo, which is our last demo, which is building a connected and a governed lakehouse. As I mentioned before, many of our customers have said that Snowflake is not the only platform that they use. They have data which is stored on many different clouds. They have data which is mapped or managed or Iceberg tables by many different catalogs. So how can Snowflake help and bring all of this together into a single governed lakehouse? And for that, we recently launched a new functionality called catalog linked databases. Catalog linked databases automatically discovers all the tables which are stored in external catalogs, brings them into together, and then empowers all of the workloads that your business teams want to do. So if your business teams want to, let's say, run an AI workload on some tables which are in Glue and some tables in Snowflake and some tables which is in Unity catalog, they can now do that, all of that together. So let's see a demo for that one. So going back to our demo account, here, let me walk through this. There's a lot of code over here. So first I'm going to create a Glue catalog integration. And this Glue catalog integration is going to point to AWS Glue, and it is using access delegation mode vendor credentials. So what this means is Snowflake has no access to the storage account where the Glue tables are stored. In fact, when Snowflake makes a call to Glue, it's going to ask like, Glue, give me the credentials for storage as well. And Glue is going to temporarily vend some credentials, and we will go and run the query on that. And then after that, some point, the temporary credentials will just expire. So this is how you can get like utmost security, where a catalog that is managing the tables will actually prevent secure storage from any other place. So I've already created the integration. Let's verify. So the integration is now successful. Now let's create a Glue catalog linked database. So what this is doing is it's created the database, and you see the linked catalog is actually to the Glue catalog integration. Now, if I look at the status says it's running, but let's see if any tables were created. So you see there is a Glue table which was created in actually the Glue database. I never created this table in Snowflake. I just created the database, and it's automatically brought in to Snowflake by catalog linked databases. If you look here, actually in Athena, there is a Glue Iceberg table over here. If you run a query, you'll see that there is one record into this Iceberg table, sample data in Glue catalog. We are bringing that sample Glue table over here. So let's run a query on that table. And you'll see here, I'm able to run a query on the Glue table, which was created in Glue. I never had to create that table in Snowflake. It was just auto-discovered and auto-brought into Snowflake. Likewise, I can create masking policies on the Glue tables as well. I'm not going to show this just in the interest of time, but I have all the code. Similarly, how we created the masking policies on Horizon table, you can now have masking policies on the Glue table also. Okay, so now let's see the Unity catalog. So I have, very similar to Glue integration, I've created a Unity catalog integration. And in the Unity catalog integration, I am pointing to the Databricks workspace, which is exposing the Iceberg REST catalog. Very similarly, I am using a access delegation mode as vendor credentials, which means Databricks is vending credentials. And now Snowflake is going to use those credentials when it runs the query. So let's verify the catalog integration. So that's successful. Now let's create a Unity catalog linked database. So Very similar to the glue one, when this database is created, Snowflake will automatically go and bring in all the tables which were in Unity catalog. So if you see, this is the catalog. So it is going to bring in this my Unity Iceberg table into Snowflake. And if we look at sample data, sample data is not available over here, but that's fine. So if we look at that database, so let's look at the link status. It says it's running, there is no failures. So now if I do a show Iceberg tables, you see my Unity catalog Iceberg tables has now been brought into the Snowflake environment itself. And now if I do a select star, I can see a sample data, the one row that we had, sample data in Unity catalog in Snowflake itself. Now let's do a crazy thing. Can we do a join between a Horizon Iceberg table, a Unity catalog Iceberg table, and a Glue Iceberg table all in the same environment itself? So let's do that. And now I'm seeing sample data from my Snowflake managed Iceberg table or a Horizon table, a Unity catalog table, and a Glue catalog table, all in the one place in one query itself. This is how you can unify your entire data estate and bring all of them together. And I want to mention one thing. I don't have a demo for it, but I want to mention one thing, that you can not only run select queries, you can also run DML queries, and we will actually do a commit call to the remote catalogs, whether it's a Unity catalog or a Glue catalog or a Microsoft OneLake catalog. We will do a remote call to them and commit the data on the remote catalogs as well. Okay, so to wrap it up, we saw how Snowflake helps you create a better enterprise lakehouse and overcome all of the challenges that we looked at earlier. Just to key takeaways, Snowflake helps you to secure your entire data estate with foundational enterprise security. It includes disaster recovery, masking policies. We saw how masking policies can also get replicated and they can be applied on the secondary deployment. It helps you conquer your data complexity by bringing everything together into a fully managed platform. No matter where your data is stored or which catalog it's managed by, you can bring everything together and still run all of the Snowflake workloads on top of that. And lastly, it just helps you empower your business teams to deliver trusted AI ready and analytics ready workloads to your business teams. Thank you.